Welcome class. This is our lecture on problems in Laplace transform. In the previous lecture, we have done properties of Laplace transform, inverse Laplace transform, and we have taken some of the civil services questions. Now, we are proceeding with this. The question says, find the Laplace transform of ft is equal to cos t, and the range is 0 to pi, and pi is on closed interval as you can see, and it is 1 for pi to 2 pi, and sin t for greater than 2 pi. Now, why have I taken this question? This question is of prime importance in the coming civil services, because in 2015 they have asked on this property of double shifting property or second shifting property. The property is f of t minus a, u of t minus a is equal to e to the power minus a fs. And when we are solving second order differential equation using Laplace transform, a lot of questions that are asked that demand us to understand the Laplace transform or to break the functions decomposed when it is piecewise. Before I solve this question, I would like to give you a general perspective on how any function f of t, if say is written as f1t in the range t less than equal to a, its value is f2t for t ranging from a to b on closed interval, and f3t for t greater than b. We can write this function as ft is equal to f1 of t u t plus f2t minus f1t u of t minus a plus f3t minus f2t u t minus b. Now we have introduced ut minus a and ut minus b. What are these? These are unit step function. Here it is shifted by a and b, and where a and b are constant and positive constants. So I will define first of all u of t. U of t is equal to 0 for t less than equal to 0 and 1 for t greater than 0. If we plot the graph, it look like this. U of t to t here, you can see on from 0 to t its value is 1, and less than t, for it is not defined for negative values. So this is very much clear. Similarly, we can say u of t minus a is 0 for t less than equal to a, and 1 for t greater than a. On similar lines, we can say for ut minus b it is 0 for t less than equal to b, and 1 t is greater than a. So I think now it is pretty much clear as to how do we write the function. So now I will take up the question. Question says f of t is equal to cos t ut plus f2 minus f1. What is it? It is 1 minus cos of t u t minus pi plus the third function, that is sin x, minus second function sin t minus 1 u of t minus 2 pi. So this is the value. Now, before we use that property, let me write the property ft minus a u of t minus a is equal to e to the power minus a f of s. Now I will break these functions. If I take as, say, m of t cos t ut. So here a is 0, so no shifting. So if I take its Laplace transform m of capital M S, then it is s by s square plus 1, and we know the Laplace transform ut. If we have to take the Laplace transform this one, because it is for the positive values. So now for the second function, say if it is g of t is equal to 1 minus cos t. Here it is shifted value, so we will write g of t minus pi. So what becomes g of t is, if we shift by pi, it becomes 1 minus cos t minus pi. So it is 1 plus cos of t. Third function, we take h t minus 2 pi is sin t minus 1. So if we take the function and shift it, it becomes sin t plus 2 pi minus 1. So it becomes sin t minus 1. So we can take the invoke here Laplace transform g of s, that is Laplace transform 1 is 1 by s plus s by s square plus 1. Similarly for h of s, we can write 1 by s square plus 1 minus 1 by s. So we use this property now and we will write our answer. So for this one, we can straight away write this function Laplace. This is our s by s square plus 1 plus, how is it shifted here? Shifted by pi. So here a is pi. So e to the power minus pi of s. And we have got the transform g of capital G of s. So we can write it 1 by s plus s by s square plus 1 bracket close plus e to the power minus 2 pi x, because here it is shifted by 2 pi. So what is the transform? 1 by s square plus 1 minus 1 by s. So this is the answer. This question is important, and such kind of question we must have a general understanding how to solve it. Now I am going to the second question, which is based on the principle of periodic function. What is happening when a function is periodic? We have definitely done a question which was asked in civil services in the previous lecture. If you want to see, you can visit our previous lecture also. And we have derived what is the Laplace transform of any function with period. We have derived and taken a question. Now I am going to write the property. That property is, if any function which is periodic, then its Laplace transform is 1 by 1 minus e to the power minus st. Laplace transform of t is equal to 0 to capital T e to the power minus st ft dt. So here t is period. So here our period is given as 2 pi by omega. Fine. And our function are broken down into two components. For values 0 to pi by omega, our function is e sin omega t, not defined on pi by omega to 2 pi by omega. So we can write it like this as 1 by 1 minus e to the power minus s. What is our capital T? That is period. 2 pi by omega. And what is this transform? T is equal to 0 to 2 pi by omega. And what is the function? Function is f of t e to the power minus s t dt. Now we will break this into two components. S 2 pi by omega. When we break components, it is t is equal to 0 to pi by omega. And what is the value of function? E sin omega t. E sin omega t e to the power minus st t plus t is equal to pi by omega to 2 pi by omega. Here the value of function is 0. So this is not factored into. All we have to do, take the integral of this. So what is the integral? 2 pi by omega s. You can take e outside and just recall the formula of integral e to the power ax sin bx dx, that is e to the power ax divided by a square plus b square into a sin bx minus b cos bx. So we will just do the same here. So here a is minus s. So minus s square is s square. B is our omega. So we can write it like a is minus s, so minus s sine omega t minus b. B is omega cos omega t, and we can put the limits. Limit is from running from t is equal to 0 to pi by omega. Let me erase this formula. So what it becomes, we can take this minus sign outside, so it becomes minus e 1 minus e to the power 2 pi omega s. We can take s square plus omega square also outside. Why? Because we have to deal with only t components. So we can write it as s sine omega t plus omega cos omega t, t is equal to 0 to pi by omega. Now this is minus e s square plus omega square, this is 1 minus e to the power minus 2 pi omega s, and if we put the limits, upper limit is pi by omega, so s sine omega into pi by omega. Omega get cancelled. Omega cos omega into pi by omega, and we have to also factor this. This was left, so this becomes e to the power minus s in front of t. What we get? Pi by omega. So if we take the lower limit is 0. So if we put e to the power minus 0, that is 1. So minus sine 0 is 0, we know it, and omega cos 0 is 1 itself. So that becomes omega itself. So what our answer is like, we will just write it down. So it is, minus sign is there, so minus e s square plus omega square into 1 minus e to the power 2 pi omega by s, e to the power minus s pi omega, and here it is cos pi. The cos pi is minus 1, so here it becomes minus omega. So it becomes minus omega, so this becomes minus omega. So we can take this minus sign outside, so it becomes e by omega s square plus omega square into 1 minus e to the power minus 2 pi omega s, and this becomes 1 plus e to the power minus s pi by omega. So we can factorize this, e omega s square plus omega square, so this becomes 1 plus e to the power minus pi omega s into 1 minus e to the power minus pi omega s, and this get cancelled. So we get e omega s square plus omega square 1 minus e to the power minus pi s pi omega s. So this was the result that we are seeking, and we have got the result. Now we will take the third question, and the question is asking us to evaluate using Laplace transform. So the question is, evaluate 0 to infinity cos 6t minus cos 4t divided by t dt. Alright, so here we are using a property, we must recall, that is Laplace transform of any function f of t by t is equal to integration s to infinity f of s ds. This amounts to, say, if we write g of t is equal to f of t by t. So this is an integral 0 to infinity e to the power minus st g of t dt. All we have to do, we have to put s is equal to 0. So for this we take the Laplace transform. So what is going to happen if we take the Laplace transform? This is the Laplace transform of gt. Alright. So this is our g of s. So what is f of t? So we are going to use this property. F of t is cos 60 by t, and another point that we are going to take is this one. So this become f of t is equal to cos 60 minus cos 4t. So if you invoke the Laplace transform, what is going to happen? S by s square plus 36 minus s by s square plus 16. All we have to do, integrate it here. So when we integrate, what is going to happen? We get it as s to infinity s by s square plus 36 minus s by s square plus 16 ds. You can evaluate this integral. Once we evaluate this integral, we get g of s, and we have to put. So we have to make a note of this. So our integration will be s to infinity s by s square plus 36 minus s by s square plus 16 ds. So what it is? If we take this integration, this is if we take this is the log of this, so this is 2 times, so it is half here. So it becomes half log of s square plus 36 minus log of s square plus 16, and s varies from s to infinity. So what it becomes, half, if we take s square common, 1 plus 36 by s square divided by s square by 1 plus 16 by s square. So we can put the limits here. If you put infinity over here, so this becomes 0, so 1. So log 1 is 0. So this becomes log of, again, s square plus 36 divided by s square plus 16. So this cancels. So what we get, half of the minus sign is there, so we will invert the numerator and denominator. So if we put here s is equal to 0, as we have said in the start, we will get our answer. So answer is half of log 16 by 36. So we can write it like this, 2 times log of 4 by 6. This get cancelled, and log of 2 by 3. So this is the answer. So we have seen what we have been doing. We are taking up the problem solving sessions, these questions are pertinent and very much relevant to this examination as far as the properties are concerned. Thanks for watching our video. Please like, share and subscribe. Thank you so much.